Hello everyone, welcome back to grade 10 applied math. We're going to do a little bit different this week. So previously I made a video for each lesson, activity. Um, this time, since all three are very similar and just variations on a theme, there's only going to be one video this week, and this is for activities 5, 6, and 7, right? So everything is based on equations of lines. We're basically just putting all the line stuff, all the linear equation things together into three different activities. The first one talks about how to graph lines. The second one is coming up with equations for lines. And the third one, A7, is talking about how to apply it to real world situations. So without further ado, let's get into it. Okay, so to put it all together, really, I could stop here. This is everything. This is everything that we're going to talk about for lines. This is how you deal with lines with this very simple looking equation that y equals mx plus b. Really, that's it. That's everything that you need to know about lines. Okay, the two parameters in math, we call these numbers parameters. Y and x are the variables. Right, x can be any number at all. That's how equations work, right? They're sort of mathematical black boxes that you put numbers in, follow some set of rules, and they spit out new numbers. So you put x in, and it spits out y's. It's like some sort of number factory. And the set of rules, in this case for a line, is you multiply by a number m, and then you add a number b, right? And the m that we multiply by, we've already come up with as the name slope. And remember that slope is defined to be the rise over the run, the change in the y divided by the change in the x. And then we add a number to it, and that's what we call our y-intercept. So lines, basically, it's always the same thing. We take a number, we multiply it by something, and then add something to it. Okay? Those two parameters that define a line, make a line unique, let's say, is m and b. Right? They could be y equals 2x plus 1. Right? I take a number, I multiply by 2, add 1. I do that for all the numbers, I come up with a line with a slope 2 and a y-intercept of 1. Okay, that's what lines are. And that is a bit abstract, I'm aware, but let's make things a little bit more concrete. Okay, so how do we use this expression, this y equals mx plus b, to come up with a graphical interpretation? So let's say I have an equation here, y equals negative a third x plus 2. I want to graph that. Okay, that's all they tell me. So already I know two very crucial pieces of information. I know the y-intercept, 2, and I know the slope, negative 1 over 3. So to graph this, it's always going to be the same thing. Okay, we're going to plot our y-intercept first. That's sort of like our starting point. And that's how we can interpret it as where we begin the line, or where we can begin our steps. So we're going to put the y-intercept, which looking at this equation, y equals a third x, negative a third x plus 2. The y-intercept is 2. So where the line hits the y-axis is 2. So I'm going to stick that on my graph right away. I'm halfway there. All right, right away, when you put that dot on there, you're halfway there. You got half the marks, really. The next thing is we're going to take our slope, and we're going to use that y-intercept to come up with another point. So we're going to go from this, because I know that my slope is negative a third. That tells me I have to rise negative 1, or go down 1, and I have to run to the right 3. So starting at my point, I'm going to go down 1 and over 3 and put a new dot. All right, so I go back here. So I put my number on, I put my dot on, then using my slope, I go down 1 and over 3 and put a new dot. And really, you're done. A line is uniquely determined by 2 points. Once you have your 2 points, all you have to do is connect the dots, and we're done. Okay? So when we graph lines, it's pretty straightforward. Put your dot on, you find the second dot using the slope, connect the dots. Okay? glorified game of connect the dots here. All right, let's try another one. So let's say y equals 2x minus 4. So again, same idea. Let's plot our y-intercept. In this case, it's going to be y equals 2x minus 4. So we're going to have to go to negative 4. We go to our y-axis and put a dot there at negative 4. And then we're going to go, careful here. So the slope is 2. So what's the rise and what's the run? Weird, eh? How do we don't have a fraction, but anytime you have a whole number for a slope, we can always make it into a fraction by putting a 1 underneath it. So in this case, my slope is 2. I can now say my slope is 2 divided by 1, because that's just 2. So that tells me I have to go up 2 and over 1. Put a new dot, and then connect our dots, and we're finished. Okay? Let's try a little bit more tricky. It's instead of being given the equation, they tell us that we have to graph a line that passes through a point, in this case 4, negative 2, and it has a slope of negative 3. So we're not given a y-intercept, right? It's actually kind of easier in this case because they give us the point. They tell us the point is 4, negative 2. So I go to my x-axis, I go to 4, I go down 2, and I put my dot. Okay, so this is my point, 4, negative 2. And now I have to take my point that I'm given and using my slope, which in this case was negative 3, or negative 3 over 1, go to my next point. So from the point I just put on the graph, I'm going to go down 3, because the rise was negative 3, and I go over 1 to the right. My dot, connect the dots, and we're finished. Okay, so maybe easier for you, maybe not. Depends on how you look at it, but it's the same idea. We put a dot on the graph, we have a starting point, and then using our slope, we go from our starting point to a new point, connect the dot. All right. So that was activity 5, just graphing lines using some information they give you. Okay. Now let's go on to 6. This is sort of going backwards. In 5, we're given information. We're asked to come up with. We're given an equation. We're asked to come up with a graph. What happens if instead they just give you some information? You have to come up with the equation itself. Okay. So we're going to start off very simple, and we're going to get to probably one of the most challenging algebra problems in grade 10 applied math. So just beware. Okay, beware. That's not a word. Just be careful. Okay. So starting off very simple. They tell us the slope is 2. The y-intercept is negative 5. So first thing we do, we write down the general expression for a line. Y equals mx plus b. General expression means this is any line at all. I can pick any number for m and b, and I can make any line that exists. Okay, this is this is the line equation. Okay, now I have to replace m with 2, like they tell us, and we're going to replace b with negative 5. And all that happens really is we get y equals 2x, subtract 5, and we're done. That's it. So we put our 2 in here, we put our negative 5 in there, and we're finished. That's very straightforward. Just be careful here. Plus minus 5, right, it becomes minus 5. So whatever the sign is on the b is the sign that happens in between. Okay. If it was b equals 5, this would be 2x plus 5. Let's try another one. And then we're getting a little bit more difficult. In this case, they give us an equation. Sorry, they give us a graph, and they want us to come up with an equation. So how are we going to solve this? So right away, looking at this, I know my y-intercept. Right? I know that this hits the y-axis at a y value of 2. So right away, I know that my b equals 2. I'm halfway finished the equation. I know that y equals mx plus 2. I just need m. So I can use my graph now to find out my, sorry, 1 second, to find out my m. I know that I'm going from this point, I'm given 0, 2, and I'm given another point, 3, 0. How do I get from the red dot to the blue dot? Well, I know I have to go down 1, 2. So I'm going down 2, I'm going 1, 2, 3. I'm going to the right 3. Now down 2 means negative. Be careful there. If you're going down 2, that's going to be a negative value. And I know that slope is just rise over run. This is my rise, -2. My run is 3. So my slope is -2 over 3. Right? So now I've given my b, I've got my m. All I have to do is plug it in, and I'm done. Okay? So you just take you write y equals mx plus b. Make sure you write this, please. Make sure you write when you're doing math, it's very important that you follow the steps. Don't just go straight to this because you're going to make mistakes. Okay? Write down the everything equation, the general equation, and then substitute in. You can skip this step. This one's superfluous. This one's not necessary really, but just be careful with the signs. Okay, so -2/3 x plus 2, and we're done. Okay, so this was a little bit trickier. We had to calculate m from our graph. Okay, so we did it. We're just when we're given the m and the b. We've done it now for when we're given a graph. What happens if instead they give us a point and a slope? They don't give us a graph though. They just give us this information. So again, first step is always the same. Nope, it's not. Sorry. Let's write. What do we know? We know that the slope is 2. So m is equal to 2. They're giving us a point, right? They're giving us an x value and they're giving us a y value. So what we can do now, this is a bit tricky here. We're going to have to use some algebra. If I know m, I know m, I know x, I know y, only thing I don't know is b. I can use algebraic methods. I can solve an equation here for b. I can replace y with 4. I can replace m with 2, right? This is our y value here, right? I stuck my y as 4. My m is 2, right? I took m here. So let's do this. Slightly different. I took the 2, I put it there. I took the 4, put it in for y, and the one was x, I put it into there. So I can work that out. So 4 is just 4. 2 times -1 is -2. Positive times a negative is a negative. 2 times -1, -2 plus b. So now I have this expression here. It tells me that 4 is -2 plus something. What do I have to add to -2 to get to 4? Do a quick little number line here. I'm at -2 here, and I want to get to 4. So I'm starting here. Add 1, 2, 3, 4, 5, 6. When I add 6 to -2, I get 4. So my b is 6. Another way you could have done that is I could have added 2 to both sides, right? If you remember solving equations, we do opposite operations. This is -2, so I'm going to add 2. So -2 plus 2, they cancel out, and 4 plus 2 is 6, and we're just left with b equals 6. Okay, so that's a little bit of algebra there. Either just use a number line to try to figure it out, or use your algebraic methods. So what do I have? I got m equals 2, b equals 6. I'm done, because all I have to do is take my equation and write y equals 2x plus 6, and we're finished. All right, so they're getting a little bit trickier. We have to use some algebra here to solve for an unknown. They're giving us m, they're giving us x, and they're giving us y. We need to do a little bit of work to get b, and then we just plug it into our equation. Y equals 2x plus 6. Okay? Now, for the hardest one. Okay, so this problem, I'm going to do this in 3 different steps, and it can be the most challenging problems. Maybe the most challenging problem we'll do in grade 10 applied math in terms of algebra. There might be more difficult problems conceptually, but just algebra, like the bunch of steps. So I'm going to go through this slowly. Feel free to just go back in the movie or in the video, sorry, and watch it again and again and again, how many times as you need. Okay. So step 1, if you're given, we want to find the equation of the line, and they're only giving us 2 points. Okay, they're giving us 1 point here, where the x and the y is 2, -1. So right now what I'm going to do is I'm going to call this one x1, call this one y1. Okay. So that I'm labeling those points, x1, y1. I'm going to label this x2, y2. You'll see why in a second. Okay, so first step, step 1 is figure out the slope from those 2 points. Right? And just as I've labeled, x1, y1 is 2, -1. The second point, x2, y2, is -2, 7. So using my expression here for slope, slope, remember, is the rise over the run. Rise is in the y direction, so it's the difference, it's the change in the y. How do I go from -1 to 7? That's what this expression is saying. Y2 minus y1 is how do I get from -1 to +7? And the run is saying x2 minus x1. This is saying, what is the change in my x values? How do I go from 2 to -2? What's the difference there? How did I go on, like you can think about it on a graph here. If I'm at 2, -1, so that's 2, -1, and I'm going to -2, 7. So how do I get from -1 up to 7? And then how do I get from -2, from +2 to -2? All right, so I can replace my numbers here. Y2 was 7. Subtract y1 is -1. So 7 take away -1. And then for my x2, my rise numbers here, x2 is -2. Take away +2. So what's that going to become? 7 subtract negative. Now anytime you see this, subtract a negative, look at this. This looks very much like a plus, and it acts like a plus. So really we end up with 8 divided by -4. And we can actually see that here, right? This was -1, and we're going up to 7. So to go from -1 up to 7, I have to add 8. Right? Adding 8. And to go from +2 to -2, I had to lose 4. So my slope becomes 8 over -4. Right? You can see it graphically here, or you can see it algebraically here. And last step, what is 8 divided by -4? How can we reduce this? It's just -2. You can plug that into your calculator, or you can see this is like a fraction, 2 over 1. However you want to see that, probably calculate is the easiest. 8 divided by -4 gives us 2. Okay, so step 1 is finished. We got our slope. As I said, these are long problems, and they're algebraically quite complicated. So first step, slope, got there. Next, now we're basically at this point, we're just like problem letter C. The problem we just did, where we're given a point and we're given a slope. We're actually given extra information. We're given 2 points. We can choose one of them, but it's the same idea. We have to solve for B. We have to get our y-intercept, and we have to do that using our algebra. So we write down our general expression, y equals mx plus b, and we're going to replace, this is our m. We know our m, right? So we got our m. We have x and y twice. We have x and a y here, we have an x and a y here. I can choose either one. Now don't mix them up, but pick one. And usually pick the numbers that are smallest. So in this case, I'm going to pick 2 and -1, just because the numbers are smaller. So if I have to do multiplications, it's just faster and easier. So I'm going to replace the y in my expression here with -1. I'm going to take the -1 in my expression, take the m, put in there, and I'm going to replace the x with 2. And we can write that out as -1. One second. Sorry, I'm going to replace the y with -1. I'm going to put -1 here on the left-hand side. And then it says m times x. So that's going to be -2 times 2, which was my x value. So -2 times 2 plus b. Now remember, if I have just brackets here, there's a hidden multiply here, but we just don't write it down because having x's makes things confusing. So -1 is equal to -2 times 2, which is -4, plus b. And again, it's asking me, how do I go from 4 to -1? Right? If on a number line, I'm starting off at -4, and I'm trying to get to -1. So I have to add 3 to that. So B is just 3. Whoopsies. My picture's gotten confused. Another way you can do that is we can add 4 to both sides of this equation. -1 plus 4, B is equal to 3. Okay, so I've got an M, I've got a B, I am done. Right? Step 1 was finding M, step 2 is finding B. All you have to do now, put them together. Right? I had an M of -2, I had a B of +3, y equals -2x plus 3, and we're done. Okay? And I say done because that was a lot. So really feel free to go back. That was what took me about 6 minutes to explain. Feel free to go back, watch it again, and that's how we do that. Okay, those are the hardest problems we're probably going to do. So pretty tricky. Okay, and again, same idea. Not same idea, but big ideas here are. Oh, what are we doing? I went too far. Where am I? That's C and D. Okay, so step 1, we get our slope. Right, we take our numbers, put them in our expression for slope, get our slope, and we take our equation for line, and we solve for B, and then we put it all together. Y equals mx plus b. Right, y equals mx plus b. We got our m, we got our b, and we're done. Phew. Okay, as I said, y equals mx plus b. That's the big idea for this whole lesson. Last thing I want to talk about is now using this for things. So applying these linear equations to problems. Let's say I want to convert inches to centimeters. Determine an equation that converts inches into centimeters given the following information. 0 inches, 0 centimeters. Okay, 2 inches, 5.08 centimeters. And so on in my graph. So what I can do now is I can take points. Right? I can use this graph. I can use this row to come up with ordered pairs. Oh, oopsies, 1 second. Sorry, I just had a little typo. Those were supposed to be y's there. Okay, so I can use my table of values to come up with ordered pairs. I'm just going to pick these two numbers. And now that I've got two numbers, I can do the same thing I did in my other problem. Right? I can take my 2 points and I can plug them into my equation, into my slope equation. Right? So in the y's, I'm going from 5.08 to 10.16. Right? I'm going, that's my y2, take away y1. And in my x, I'm going from 2 to 4. So what's the difference? So it's just going to end up being 2.54. Right, I'm going to work this out. So 10.16 take away 5.08, it's just 5.08. 4 take away 2 is 2, and then 5.08 divided by 2 is 2.54. So we have half the problem done. We have our m. What about b? Do I have to go through all that algebra stuff? No, not in this case. Because I know that, if I go back here, 0 inches is 0 centimeters. So what's that means it has to go, if I drew a graph here, there has to be a point at 0, 0, at the origin. So whatever the line is, what's the y-intercept? 0. Okay, so this is pretty easy because we know that there's the point 0, 0, so therefore the slope, the y-intercept has to be 0. Okay. Now I'm going to do something a little bit different. Okay, so since we're talking about a problem involving some very special, like not special really, but specific variables, in this case inches and centimeters, using x and y can be kind of tricky. So what we're going to do is we're going to use what we call let statements to define letters to represent variables in a more intuitive way. So let's say now that I is going to represent inches. Makes sense. The word inches starts with the letter I. So I equals inches. and c is the number of centimeters. So when I take my expression, usually of y equals mx plus b, this is going to change slightly. I wanted to determine an equation that can convert inches to centimeters. So my input, my inches are in, that's going to be my x value. And I want centimeters coming out, that's going to be my y value. Right? My inches are my, I always get this mixed up, the independent variable, and the centimeters are the dependent variable. We want to put in, it's a determine, convert inches. So I have 12 inches, 16 inches, 42.36 inches. That's what I'm going to put into my expression, and I want it to spit out, give me centimeters. So my equation, or if you missed that, y equals mx plus b becomes c equals my, not x, I plus b, right? The y became c and the x became I, just like in our let statement. And I know that my slope was 2.54 from the previous calculation, and I know that b was 0, so my expression for number of centimeters as a function of inches is just 2.54i. C equals 2.54i, and we're done. There's an expression that'll convert inches to centimeters. So we can use it. How many centimeters are there in 72.3 inches? My expression is C equals 2.54i, multiply 2.54 times 72.3. It gives us a final answer of 183.642 centimeters. And we're finished. Okay? All right, so that's all I wanted to talk about for this lesson for 5, 6, and 7, for activity 5, 6, and 7. Okay, so I know this is a bit longer video, but instead of having 3 videos on very closely related subjects, I thought we'd have one, all of it. Okay, so I'll be uploading this video to our D2L and to Teams, and as well as the worksheets. All right, so good luck, and I'll be talking to you later. Take care, guys.